So this is just a little L'Hopital rule summary. I want to make sure that you're really solid on this as we move forward into some challenging material this next week, and you've got a quiz the following week. Okay, so when is it you can use L'Hopital rule? L'Hopital rule you can use when it's in 0 over 0 or infinity over infinity. Okay, so that's when the tool, so you want to think of this as a tool. This is helpful to do limits. So looking at this, there's a messy infinity, but here's x's go to infinity. If I plug in infinity, I get infinity times, and if I put infinity in here, remember don't write it, but I'd have pi over infinity, which would be 0, and sine of 0 is 0. Oh, 0 times infinity. I cannot use L'Hopital rule. It's not L'Hopital ready. So I have to put one of them in the denominator. And I want to always encourage you to put the easier one in the denominator. So I'm going to say, put the x in the denominator as 1 over x. Now check it. Is it L'Hopital ready? Put in infinity. I get pi over infinity 0. Sine of 0 is 0. And if I put infinity in here, I get 1 over infinity. That's 0. So it is L'Hopital ready. All right. So carrying the limit along every time, take the derivative of the sine, you get cosine, carry the angle along, now take the derivative of this, and so I get negative pi over x squared, all over negative 1 over x squared from the derivative of the denominator, right? So hopefully you're all good, right? Pi over x, taking the derivative. It's the same thing as saying pi x to the negative 1, so that's negative pi x to the negative 2, or negative pi over x squared. Okay, so I see there's some canceling going on, so I'm going to be careful. So I see that it's a negative 1 over x squared and a negative 1 over x squared, but there's a pi here, so I'm going to pull the pi out front. And so then I'm just writing it one more time, mostly just so you can see it. So these cancel. Now go plug in infinity. So I have pi over infinity is 0. Cosine of 0 is 1, and then I get pi. Okay, so that's if you have a 0 times infinity. So the method is put one of them in the denominator. So here's this other case. What happens if I have something like this? If I put in 1, I get 1 over 0 minus, I know that ln of 1 is 0. 1 over 0, we call it infinity. So this is like saying infinity minus infinity. All right, so that is an indeterminate form. I cannot use L'Hopital. So what I need to do is make common denominators. So I'm going to make common denominators, so I'll get x ln of x here minus x minus 1 all over x minus 1 ln of x. Be careful with the parentheses, right? Because the subtraction sign has to go to both of those terms. All right, so let's just take a moment and just so we don't make any mistakes, minus x plus 1, okay. And then I could even multiply this out, right? So you don't have to use, well, I guess you still need to use product rule, but all right, so there we go. Okay, now check it. Is it L'Hopital ready? Plug in 1, ln of 1 is 0, so that's 0. Negative 1 plus 1, that's a 0. Plug in 1, ln of 1 is 0, ln of 1 is 0. I get 0 over 0. So it is, in fact, L'Hopital ready. So let's do it. Okay. Oops, going to 1, go to 1. There we go. So product rule here, right? First d second plus second d first. Take the derivative of this negative x gives me a negative 1 over, again, product rule, first d second plus second d first minus the derivative of ln of x. There we go. Okay, so be really careful with this. These two terms right here, right? X over x, that gives me a 1. So I'm going to go slow. 1 plus ln of x minus 1. This gives me a 1 plus ln of x minus 1 over x. So now I can see these two 1's cancel. So I'm left with ln of x in the numerator, and then 1 plus ln of x minus 1 over x. Now plug in 1. So ln of 1 is 0. I get that on the numerator. I have 1. ln of 1 is 0 minus 1. 0 over 0. So yet one more time. So derivative of ln of x is 1 over x. Take the derivative of this is gone. The derivative here gives me 1 over x. The derivative of this will give me a positive 1 over x squared. Now go plug in x equal 1. 1 over 1 plus 1, or 1/2. Okay, so L'Hopital rule is a tool to take limits, and it only can be used on those two types.